This presentation will introduce time series databases, which are specialized storage solutions for time-based data. Let's explore what makes them unique and why they are essential for certain applications. Time series databases are specialized database systems optimized for storing, retrieving, and processing time-stamped data points collected at regular intervals. These databases are designed to handle data where time is a critical component. Here are some key points to remember. They are optimized for time-based data collection. They have high write throughput for continuous data streams. They provide efficient time-based queries and aggregations. They have built-in data retention and downsampling capabilities. Time series databases possess several characteristics that set them apart from traditional databases. First, every data point is associated with a timestamp, making time the primary axis for data organization and querying. Secondly, they are optimized for ingesting large volumes of data points at high velocity from multiple sources simultaneously. Time series databases use specialized query languages and functions for time-based operations like aggregation, downsampling, and interpolation. They also utilize advanced compression algorithms specifically designed for time series data patterns to reduce storage requirements. Time series databases are used in a wide array of applications that involve time-based data. Some common use cases include IoT monitoring, where sensor data from connected devices is collected and analyzed at scale with efficient storage and retrieval. They are used for infrastructure metrics, tracking server performance, network traffic, and application metrics for IT operations and observability. Financial data, storing and analyzing stock prices, trading volumes, and other market data for algorithmic trading. Environmental monitoring, tracking weather patterns, pollution levels, and climate data for research and forecasting. Healthcare analytics, monitoring patient vitals, medical device readings, and health metrics for clinical analysis. Industrial telemetry, collecting machine data for predictive maintenance and operational efficiency in manufacturing. InfluxDB is an open-source time series database designed to handle high write and query loads for timestamp data. It is built from the ground up to efficiently store and retrieve metrics and events. Here are some key features of InfluxDB. It is purpose-built for time series data. It supports high-performance data ingestion. It uses SQL-like query language, which is called InfluxQL. It also uses Flux scripting language for data analysis. It has built-in data retention policies. InfluxDB organizes data using a specific data model optimized for time series. The key components are measurement, which is similar to a table in SQL databases, and contains time series data for a specific metric. Tags are metadata key value pairs that describe the data. They are indexed for fast queries and used for filtering. Fields are the actual data values being stored, not indexed but can be queried. Timestamp is the time when the data point was recorded and is automatically indexed. InfluxDB supports two primary query languages for interacting with data. InfluxQL, which is similar to SQL, allows users to select data, apply filters, and perform aggregations using a familiar syntax. Flux is a functional scripting language designed for more complex data transformations and analysis pipelines. It provides powerful capabilities for manipulating and analyzing time series data. Time series databases offer numerous advantages for handling time-based data, but they also come with certain challenges. Advantages include optimized storage formats specifically designed for time-based data patterns, high-speed ingestion of millions of data points per second, efficient time-based queries and aggregations, built-in data retention and downsampling policies, and specialized time series functions for analysis and forecasting. The challenges include limited support for complex joins and relationships compared to traditional databases, potentially high resource requirements for large-scale deployments, learning curve for specialized query languages, balancing between data retention and storage costs, and cluster management complexity in distributed setups. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.